Hi, I'm Dr. Anjaneya Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to discussing about potable water and its treatment. So, what is potable water? So, it is defined as water that is suitable for human consumption. Either it can be used for drinking or cooking. The term implies that water is drinkable as well as safe. Drinkable water means it is free from unpleasant odors, tastes, colors, and within the reasonable limits of temperature. So it contains no toxins, carcinogens, pathogenic microorganisms, and other health hazards. So water which is suitable for drinking water is known as potable water. So let us see the important or major characteristics of potable water. So it should be clear and odorless. Potable water should be free from disease producing microorganisms and germs. It should be cool and pleasant to taste. It should be free from harmful bacteria and suspended impurities. It should be free from dissolved gases like carbon dioxide, hydrogen sulfide, and ammonia, and some poisonous minerals like lead, arsenic, and manganese, etc. It should be free from dissolved minerals like nitrates and nitrates, etc. It should be reasonably soft. So, what is a soft water and what is a hard water? We know that. So, it should be soft. So, TDS levels, total disaster should be less than 500 ppm, and pH of potable water should be 6.5 to 8.5. And coming to the turbidity should be 10 NTU. And fluoride content, it should be 1.5 ppm. And chloride content, that should be 250 ppm. And alkalinity should be 600 ppm. So these are the important characteristics of potable water. So it should be free from disease producing agents or microorganisms, and it should be free from harmful bacteria and suspended impurities, and it should be free from dissolved gases like carbon dioxide, hydrogen sulfide, and ammonia, and some poisonous minerals like lead, arsenic, and manganese. And it does not contain dissolved minerals like nitrates and nitrates. Potable water should be soft, and TDS levels for potable water is less than 500 ppm, and pH of the potable water should be 6.5 to 8.5, and chloride content is 1.5, and chloride is 250 ppm, and alkalinity should be 600 ppm. So these are the characteristics of potable water. Look at this. This is the water purification plants. Here there are several stages of water purification. procedure. So groundwater which is passes through this, some coagulation has to be added, and raw water and coagulants are mixed in coagulation and filtration basin. After that, water is passes into the sedimentation basin. So sedimentation procedure will be takes place in sedimentation basin. After that, there should be polymer added to remove the impurities present in the water after sedimentation. And next passes into the filtration. When water passes into the disinfection base, before going to the disinfection base, fluoride and disinfectants will be added. After disinfection of the water, corrosion control process will be takes place. Finally, pure water will be stored in storage basin. So this diagram represents different stages of water purification procedure or process. So let us see one by one water purification steps. So coagulation. So first step of water purification is nothing but coagulation. When particles are slow to settle or non-settle, chemicals with a positive charge such as aluminum are added to the water. These act with the unwanted particles to form large particles called floccules. The larger size and weight of the floccules then causes them to settle rapidly. Next step is flocculation. Flocculation follows coagulation. When chemicals are added to the water and gentle mixing occurs to form larger particles called flux. Additional chemicals may be added during this step to aid in forming the flux. Both coagulation and filtration are effective at removing the fine suspended particles that attract and hold the bacteria and viruses to their surface. These first steps can remove up to 99.9% of the bacteria and 99% of the virus from the water surface. They also remove some of the organic matter that gather as water travels across the landscape from raindrop to river. However, certain taste and odor problems may be remains. Next step is sedimentation. As flux are formed, the large size and weight of the flux causes large particles to settle rapidly. These particles settle because they are heavier than water. And some particles will spontaneously settle out from standing water. So this is the sedimentation process. Next step in water purification is filtration. Filtration occurs as the water passes through filters that help remove even smaller particles. One of the oldest and simplest process used to treat water is to pass it through a bed of fine particles, generally sand. This process of sand filtration usually removes fine suspended solid matters as well as some other particles such as large microorganisms. Filters can also be made of layers of sand, gravel, and charcoal. The development of new synthetic materials has led to a new range of filter materials and methods. Process based on these materials are used increasingly to treat water for urban and industrial purpose. In membrane filtration, water is filtered through tiny holes in membrane or rather than bed of sand. So that is about filtration process. And small pore size and more materials is held by the membrane as water passes through of the different kinds of membrane filtration process. So it is an effective treatment in simple to operate and requires less constant operational controls. There are two other membrane filtrations with even small folds, that is ultrafiltration and nanofiltration. These two filtration processes are widely used. Adsorption. While coagulants often combine with filtration, we remove most of the troublesome contaminants from water. These processes do not usually remove all the materials dissolved in the water. If the water contains undesirable impurities, additional treatment such as adsorption and oxidation may be required. Adsorption is a form of chemical filtration. It involves removing dissolved substances by chemically or physically binding them to the filtered materials. It is quite different from similar sounding process of adsorption. In water treatment, specialized absorbent materials such as activated carbon and ion exchange resins are used to remove certain soluble contaminants from water. One way of using activated carbon is to percolate water through a bed of carbon granules. Once the carbon is saturated with the contaminants, it needs to be replaced or regenerated by heating it to a high temperature. If water contamination occurs only occasionally but can be detected by a regular monitoring program, a better approach is to be added powered activated carbon to a conventional coagulation and filtration process and a problem arises. The saturated carbon is corrected in filters and then discarded when the normal surge from the water treatment plant. This form of intermittent dosing is widely used where there are occasional problems with blue-green algae blooms, which can cause taste and odor problems and can also be toxic. Next, chemical oxidation. Oxidation with chemicals such as ozone or chlorine dioxide, a common treatment technology in Europe, has appeared in Australia only recently. So, strongly reactive chemicals such as ozone are used to disinfect water and to destroy soluble contaminants such as algal toxins, taste and odor compounds, and particularly in Europe and traces of pesticides. Water stabilization and pH control. Let us see how we can stabilize the water and pH control. Some water supplies can become acidic or alkaline by dissolving or reacting with the material they are in contact with. This can cause piping systems and hot water services to corrode and causes dissolved materials to appear in the water. For example, a common sign of copper corrosion is a brush stain where a tap drips onto the surface. To prevent corrosion, many waters are chemically stabilized to a particular pH before distribution. This is done by adding lime and sometimes carbon dioxide. Water disinfection. Water disinfected to kill any pathogens present in the water supply and to prevent them from regrowing in the disturbing systems. Without disinfection, the risk from waterborne disease is increases. The two most common methods to kill microorganisms of water supply are oxidation with chemicals such as chlorine, ozone, or irradiation with UV lights. Removal of microorganisms. So this process of removal of microorganisms from potable water is known as disinfection or sterilization. By disinfection, disease producing bacteria and germs are destroyed. Chemicals used for disinfection or sterilization are called disinfectants. Chlorine, chloramines, bleaching powder, and ozone, etc. are important disinfectants. Disinfection can be achieved by passing UV radiation. So by bleaching powder, potable water treatment with bleaching powder. So it is used to purify the drinking water from microorganisms. The purification process is achieved by dissolving 1 kg of bleaching powder in 1000 kiloliters of water. So when you are adding bleaching powder to the water, so it produces hypochlorous acid. So this hypochlorous acid acts as a powerful germicides. So it will kill the microorganisms present in the water. Water will be purified. So that is a disinfection by bleaching powder. So CaOCl2, this is a bleaching powder. So when you add bleaching powder into the water, forms calcium hydroxide. After that, calcium hydroxide converted into HOCl, that is hypochlorous acid. So hypochlorous acid acts as a disinfectant. So it can kill the microorganisms present in the water. Next one is by chlorination. So chlorination is a process of purifying the drinking water by producing a powerful germicide like hypochlorous acid. When this chlorine is mixed with water, it produces hypochlorous acid, which kills the microorganisms present in the water. So usually chlorine is a basic. It means the pH value is chlorine is more than 7. So disinfectant and is much effective over the germs. Hence, chlorine is widely used all over the world as a powerful disinfectant. So chlorinator is the operator which is used to purity and water by chlorination process by adding chloramine. So when chlorine and ammonia are mixed in the ratio of 2:1, a compound that is chloramine is formed. So chlorine plus ammonia gives rise to chloramine. And further chloramine convert into hypochlorous acid. So once hypochlorous acid is formed in water, it will act as a disinfectant. It can kill the microorganisms present in the water. And next one is ultraviolet disinfection of water. So water obtained from natural sources such as dams, streams, wells and rainwater tanks may contain microorganisms that can pose a risk to your health. The Department of Health recommends that our naturally sourced water should be professionally tested and treated before it is used for drinking, bathing, filling and swimming, and preparing foods. A number of water treatment systems can be used to remove microbiological contaminants that may cause illness. UV light disinfection is one water treatment system that can be used to remove most forms of microbiological contamination from water. So next one is ozonization. So what is ozone water treatment or ozonization? So it is a water treatment process by using ozone to purify water, that is removing microorganisms that can make you sick from drinking water. This process has been used in drinking water plants since 1903. Where the first industrial ozonation plants was built. So how do we produce ozone? By electrical discharge. It is also known as corona discharge. High voltage electricity plus dry air or pure oxygen, then O2 is converted into O3. Next one is electrolytically. So this is a very simplest method to produce ozone. This process is more expensive than electrical discharge and is same as above, but there we use acid instead of oxygen. As photochemically. Photochemically, oxygen react with nascent oxygen in presence of UV rays from bulb. So ozone will be formed. So in this process, ultraviolet radiation used for making ozone is obtained from red bulbs. How does ozone work? Ozone will initiate a series of reactions in water that are very complex and quite specific to water being treated. Ozone reacts with water or any aqueous solution in two ways, that is cycloaddition. So on unsaturation bonds as a dipole, electrophilic on molecular size with strong electronic density, and nucleophilic on molecular size with an electronic defect, and indirectly via radicals formed as it decomposes in water. A few such medicals are as follows: hydroxyl radical, hydrogen peroxide radical, superoxide radical, and ozonide radical ions. So, ozonization by indirect methods by these ions. Next, what is the main advantages of ozone water treatment? So, it is a very effective and rapidly reacts with bacteria, viruses, and has stronger germicidal properties than chlorination. So, ozonization is the better and advanced treatment by chlorination. So, it is a very strong oxidizing power with a short reaction time. The treatment process does not add any chemicals to water. Ozone can eliminate a wide variety of inorganic and organic and microbiological problems and taste and odor problems and disadvantages of ozone water treatment. Ozone water treatment is much expensive than other treatment levels. In ozone water treatment, there must be professional proficient for water treatment and system maintenance. It does not provide any germicide or disinfection residue to prevent regrowth. Due to its less solubility in water, special mixing techniques are needed. Fire hazardous and toxicity issues associated with ozone generation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.